nothing we do in life that accelerates that fast, right? In a car, your head would snap off and roll backwards. So, but there's not only that, there's some rotation of the wrist. I mean, there's a lot of sort of joint action going on there, and you capture all of that. I was very impressed by what this is and what it can do for us.
Thanks for saying that. And it's really Elida who identified that beachhead market, and I've been fascinated with it. And yes, in 2 seconds, 100 miles per hour, but how fast does it get, in the first 80% of that velocity? How does it, what time duration does it achieve that? And we think it's, and this is backed up by some other data, that it happens in like very soon in the pitch. And then this is also why people with longer arms are viewed as better pitchers, because they can apply that acceleration for longer periods of time. Or they can do the same speed by accelerating at a slower rate over a longer period of time, which can preserve their joints for longer. But we have examples of pitchers who defy that. And then how do they defy that?
Like Pedro Martinez was not a tall pitcher for the Red Sox.
Or
I think he might have been sub 6 feet.
Tim Lincecum was 5'10", I believe. And if you look at his biomechanics, he extends most pitchers will pitch over something like 85% of their wingspan. They'll move that, but he did it like 125% or something like that. There's all kinds of stuff going for biomechanics and injury reduction, and these it's great that systems like what are they, TrackMan and
Paul Guy, TrackMan,
all of these motion capture systems that are out there now, and some are even getting higher in sampling rates, are providing all this information, but being able to have that unobscured at rates, I mean, there's really nothing limiting it. We could potentially do millions of samples per second, versus.
And they all use cameras. They all use cameras.
See, the thing is,
you're at the actual source.
Yeah, exactly.
There is not a sport that will embrace detailed data like this, like baseball.
Yeah, that's true.
And the GMs are going to love you.
They'll eat it up. We got to take a quick break. When we come back, we're going to find out what the future of all of this can be, because just to have this capability, oh my God, there are solutions that people didn't even know they could attain once they had until now that they have access to this technology. We're going to hit that up in the third segment of Star Talk Sports Edition when we return. We're back, Star Talk Sports Edition. We're talking about the future of monitoring what your body is doing on the inside, but you're doing it from the outside with this magic material that our two guests have pioneered, and I think I perfected your names here. So you have
Elida. That's good.
Good. Elida Shamilgi.
You moved to an A- from B+.
Okay, thank you. And Rob Shepard. You guys are mechanical engineers, but you're into robotics. You're into robotic monitoring of the human condition. And sports has a huge benefit from this, particularly which we spent time in the last segment. The rate at which you can gather information on something that is moving fast and is non-repetitive is without precedent. So what are your best applications today, and what do you see coming down the pike tomorrow?
Yeah, I think as we briefly discussed earlier, the best application right now would be baseball and pitchers specifically, because of the high-speed motion they go through and how often they could go through that motion, which usually results in injuries. It's very common to have a Tommy John surgery there. But whether we see this in the future, like I said, we want to make full body garments, not just shirts or not just straps, but also leggings, shoes, socks, really anything you want to measure or any area you want to measure. And we want to apply not only to sports, but also provide medical benefits like clinical application, physical therapy. We've looked into robotics, of course, and even car seats. We had interest in measuring comfort levels, driver attentiveness. Did you forget your child? It happens a lot in a car. So
hey, it only happened twice.
Okay. And the third time it was on purpose. Right.
No judgment.
No judgment. Yeah, look, when you Elida, when you discuss those applications outside of the sporting realm, I'm sitting here wondering, and I'm not a computer gamer, but this sounds like it is absolutely set to walk itself into VR and AR. Now, has that universe come to you?
Yeah, definitely. I'm surprised I forgot to mention that, but the why is so there are two different routes we can go for when it comes to AR, VR training. We can do training. So instead of just seeing a reconstruction of your hands or your body in the VR environment, you'd also receive feedback on how much force you're applying to. So if you're learning, say, medical training, you need to know how much exactly to push when you're doing a surgery, and you could get that measurement with our sensors if you were wearing them. And then gaming, the same thing. Instead of just seeing your body in the VR environment, you can get feedback on how much you're pushing, how much you're pulling something, what that results in the gaming environment. So it makes it more real.
Yeah. So now this is information flowing in one direction. Do you have the ability to send information back? So, if I'm talking for corrective purposes. So if I'm throwing and your fabric is saying, hey man, what you're doing right now is you're stressing right here in this part of your rotator, boom, and if you continue to do that, we know what's going to happen. But at the point where it's happening, is there a signal that can be sent that lets me know, oh, I just did that? And then if I don't feel that, oh, I did it right, that type of thing.
Yeah, there are a couple of different ways we can do this. One of them being we can send information back via different light patterns. So our sensors glow. We can make them not glow, or we can make them glow in different patterns. So maybe having them glow 3 times or having them glow red could mean you are about to get injured, you should stop. We could have them glow green to mean something else. And the other way to go with this is have the app tell you. So if you have your phone or iPad or the device in front of you, it could also just tell you there.
It is great feedback, Chuck. We'll build that in there. Another thing we do is put a little vibrotactile thing in the pod. Like I said, this has an electrical portion too, which is located, a small pod located, depending on the garment.
You're gonna make garments glow and change color. You're gonna sweep up the teen market. You're gonna get the 20-somethings. You're gonna get the 30-somethings and the 40-somethings who still think they're 20-something.
Not to mention all the ravers that will go into a club and get rid of their light sticks so that they can just use their shoulders.
That's it. That's what I'm saying. So look, I gotta ask you now. And what you're doing is incredible, but now, is there a dialogue between your
Wait, Gary, I find what they're doing entirely credible. It's not incredible. It's entirely credible.
Thank you. That's great.
Yeah.
I stand corrected. Sit corrected. Are you now in discussions with biomedical engineers? The work that biomedical engineers are doing, trying to map and code signaling for neural signals, how long before you guys talk to them and you come up with something together?
This is where we both work on wearables and robotics, which is prosthetics. And so measuring signals from the outside world and transmitting it to our body through electrical impulses is something we have worked on in the past and are continuing to work on, but it's such a long slog. And
well, electrical impulses that you feel on your skin, or that you somehow impart into the brain?
That you would impart into sensors in your skin, which then would send that information to the brain.
Right.
Yeah, and
It's almost the same thing, right? Because your brain is sensing the rest of your body.
yeah.
Right.
And,
Oh, no,
and
si c'est moi la
we
kicker, elle est
worked
magnifique.
on the hardware part, which is making a prosthetic hand that actually is pretty good, and it's lightweight,
Yes, papa.
high force,
Bien joué, les gars.
feedback controlled and everything. And it's quite simple, at least for us, to add the capability for that hardware to output electrical impulses that could be then used.
So something I saw that you've been working on is embodied energy systems. And I've seen a little tiny
Moi,
little
Cortex,
video
pourquoi je préfère
of
le
your
normal?
soft aquatic robot, which I
42-10 au couteau.
but it's been called a soft aquatic robot. So talk to me about embodied energy systems, because I think that's going to talk Chuck out.
Oh, yes,
Yeah,
Papa.
so if you look at the best example of a general purpose robot today, I think is Spot from Boston Dynamics, that yellow quadruped that walks around.
Yes.
So we can do that for